Okay, today we're doing absolute value equations and absolute value inequalities. So there's a two-part setup for solving them. Okay, step number one, isolate the absolute value. Your first step is to get the absolute value by itself first. Okay, so if you have anything with the absolute value, you have to get rid of those other things first. Okay. Once you isolate the absolute value, then you split it into two problems. And this is where most students screw up. Either they don't make two problems out of it and only get half credit. Because if you only do half the problem, you're only going to get half credit at best. Okay. Or they don't split it properly. Okay. It's not a difficult, this is the only part of it that's hard, is the splitting, and it's not difficult, it's just a little complicated. So you have to pay very close attention to when we do these and how you do them. Okay, so there's an example here. So I have the absolute value of x minus 18 equals 5. So when you split it, you're going to take it the first time you do it. You're going to rewrite it as two equations without the absolute value. You cannot solve it with the absolute value on there. You have to remove the absolute value, and to do that, you break it into two problems. And the first one is exactly the same as what you have. X minus 18 equals 5. It doesn't change except you drop the absolute value bar. That's easy. Everybody gets that. Okay. The second one is where it's complicated. You ignore the bar, so I still have just the x minus 18. And because it's an equation that's equal, only it's equal to negative 5. You change the sign. You do it once where it's equal to the number and once where it's equal to the opposite of the number. So I have it equal to 5. I have it equal to negative 5. And then I solve those, giving me two answers. Okay? That's what you do when you solve an absolute value equation. You have to split it into two problems. Equal to the number, equal to the opposite of the number. Notice what was inside the absolute value, x minus 18. This does not change. That part doesn't change, and that's a common mistake students make. Is that, oh, anywhere there's a negative, I make it positive. Anywhere there's a positive, I make it. No, you don't do that. You only change what's outside. Okay. So let's work a couple of examples here. So the first one, absolute value of x plus 2 equals 9. Well, remember our first step, isolate the absolute value. So my first step is to get the absolute value by itself first. So the first thing I'm going to do is subtract 2 from both sides. And that gives me the absolute value of x equals 7. First step, get the absolute value by itself first. If it's already by itself, you're good. If not, you need to get the absolute value by itself. Absolute value of x equals 7. Now we split it into two problems. Always two problems. This is how I always do it. I draw the two lines. Ooh, here's my split. Helps me keep track of what's going on. I have what's inside equal to what's outside. No changes except for losing the bars. And then I have what's inside equal to the opposite. So x is equal to 7. X is equal to negative 7. That's my answer. Okay. And if you have a number line like this, you need to graph it. Dot at 7. Dot at negative 7. Okay. Not difficult, just a little complicated. So, second problem. My first step is to isolate the absolute value. Ladies, first step, isolate the absolute value. I already have that. I have the absolute value by itself. I don't have to do anything else. Now I do the second step. I go straight to that. I split it into two problems. Exactly as it is without the absolute value bars. X minus 2 is equal to 4. And then what's inside equal to x minus 2 equal to what? Negative 4. Like I said, it's not terribly difficult, just a little complicated. And now you solve these two problems. Add 2, x equals 6, add 2, x equals negative 2, negative 2, negative 2. So I have negative 2 and 6, so I have a dot at 6, and a dot at negative 2 if you have a number line. If you don't worry about it. Okay, I'm more concerned with can you solve the problem. Bless you. Questions so far? Okay, got a word problem. Solving an absolute value equation. Starting from 100 feet away, your friend skates towards you and then passes you. She skates at a constant speed of 20 feet per second. Her distance from you in feet after t seconds is given by the equation. D for distance equals the absolute value of 100 minus 20t, t for time. Excuse me. At what time is she 40 feet from you? How many times is she going to be 40 feet from you? Once. Once when she's 40 feet that way, and once when she's 40 feet that way. Okay, because she passes you. She's 40 feet in front of you, goes past you, and now she's 40 feet behind you. So she's 40 feet twice. Absolute values will cover giving it to you twice when that happens. Okay, so the idea is when is she 40 feet? That means your distance d is 40. So I take this, replace it with 40. So I have the equation, the absolute value of 100 minus 20t is equal to 40. And I need to solve that to know where she is, how long it takes her to get 40 feet away, before she gets to me, and then 40 feet when she passes me. Okay. So absolute values by itself, split it into two equations. 100 minus 20t equals 40, and 100 minus 20t equals negative 40. And then you solve it. Easy problem, two-step equation. Subtract 100. That gives me negative 20t is equal to negative 60. Divide both sides by negative 20. T equals 3. Same thing on the other side. The exact same steps to solve. I'll just have a different answer. I still subtract 100. Gives me negative 20t is equal to negative 140. Once again, I still do the same step of dividing both sides by negative 20. T equals 7. So 3 seconds. Takes her 3 seconds to get 40 feet away. She passes me. 7 seconds to get 40 feet behind me. Questions? Okay, those are equations. Sometimes with absolute value problems, you will get a no solution. It doesn't work. Okay, sometimes it happens. You don't always know when it's going to happen right away, but sometimes it does happen. So my first step on this equation is to isolate the absolute value. So I want to get this by itself. So my first thing is to subtract 12 from both sides. So I get 3 times the absolute value of 2x plus 9 equals negative 2. Now, divide both sides by 3. Those cancel. And I get the absolute value of 2x plus 9 equals negative 3 halves. I'm done. Absolute values of numbers are always what? They're always what? Positive. Absolute values are always 0 or larger. Can I take the absolute value of any number and get negative 3 halves? No, you can't. Because absolute values are always positive. Whatever I put in here will be at least 0. Whatever I put in here, the absolute value of anything will never be negative 3 halves. If you have the absolute value equal to a negative number, you have no solutions. Nothing will work because it doesn't matter what you put in there. When you take the absolute value, you get a positive number. And a positive number will never be equal to a negative number, no matter what. Okay, so sometimes you will have no solution with absolute value. If you get the absolute value equal to a negative, you're done. Because you can't get a negative number out of it. Okay. Now we get to the fun part. And it's almost identical to what we were doing with one key exception. Okay. We're still going to split it into 2 problems. Actually, let's do this. So, first step, just like the other ones, I just copied down exactly as it is without the absolute value bars. 8n is greater than or equal to 24. Okay. First problem. Second problem, 8n, and change the sign, negative 24. When we change the sign, we also flip the inequality. That's the thing you have to watch out for on this one. When I go from positive to negative, I go from greater than to less than. When you change the sign, you flip the inequality. With equals, it doesn't matter. Both inequalities, you flip the inequality around. And now you solve these 2 problems. Easy peasy. Divide both sides by 8. N is greater than or equal to 3. Divide both sides by 8. N is less than or equal to negative 3. Negative 3 with a dot, everything smaller. Positive 3 with a dot, and everything bigger. Okay. Second one, same thing. Try to set it up on your own first. Just split it. Don't worry about solving it, but I want to see if you can split it correctly first. Remember, what's inside never changes. It's only the stuff outside that changes. So I have the first one, x minus 4 is greater than or equal to 1. And on the other side, I have it, what? Less than or equal to negative 1. Change the sign, flip the inequality. Add 4. X is greater than or equal to 5. Add 4. X is less than or equal to, not negative 3, my bad. 3. Yeah, that is true. Sorry, forgot. I just go with the answer and then that tells me whether it's an and or or. So Ms. Kersey brought up a very good point. Are these and problems or problems? And the best way to tell is you look at the answer. It goes out, we got horns, so that means this is an OR problem. Okay, I always let the final answer dictate to me whether I have an AND or OR. If it goes out in opposite directions, I have an OR. This one here, I have 5. Going out, I have 3. Going out, this one is also going to be an OR problem.
Greater than is always an OR. Greater.
Ooh, I hadn't thought about that one. Okay, and these are less than. Same idea. First step is going to be isolate the inequality. We don't have to worry about that, so we split it into 2 problems. It works the same way. W minus 213 is less than or equal to 5. W minus 213 is greater than or equal to negative 5. Ladies, please. Okay. So once again, switch the sign, switch the inequality. And then from here, solve it. Add 213. W is less than or equal to 218. Add 213. W is greater than or equal to 208. And if I were to graph them, it would be going in between. This is less than, that means it's in and A and D, not A and A. Questions? Okay.